Okay, another vlog entry for you here. So I've done some more work on the SkittleBits CPU here. Added some more peripherals and some more features and whatnot. And yeah, I suppose I could just dive right into it and show you what's new. So for one, there's some nice pixel art in the center of the programmer's area right here. Just thought I'd add that for shits and giggles. We've got some more controls. I'll go into those in a sec. Got some more bells and whistles and a lot bigger bells and whistles, and yeah. So let me start with the big one. I guess this one is the big feature that I added here. So initially the system was built with 32 byte. That was interesting. That was Steam. Initially the system was built with 32 bytes of RAM, which was this section over here. The memory capacity has been extended to 64 bytes of RAM, so now you can fit even larger pointless programs in here. That actually came out of necessity because I was trying to test some I/O peripherals, and I was writing programs that were very quickly exceeding 32 bytes, so I just figured, okay, what the hell, throw in another 32 bytes, so now we've got a 64 byte memory capacity, which I think should be fairly adequate. I designed the modules in such a way that they can be stacked, so if we need more memory, we just take the module right here and stack it on top of each other to add more memory. Of course, we do have to add more address lines, and we're getting quite a bit of lag. Thank you, 1.9. You do have to add more address lines, but that's not that big of a deal. Everything else is pretty much ready to go. So all you have to do is just stack it at the lines, and it's, yeah. So that's that. What else? So the next thing that I added over here was, this is a general purpose input-output port, or GPIO port. And the purpose of this is, it's not necessarily to bring in a byte or bring out a byte. This actually is 8 individually programmable input-output pins. And so you can say you can set like 7 of the pins to outputs and 1 to input, you know, or you can set half to an input and half to an output. They're totally, you know, independent of each other and can be programmed in any way you like. And so the way that works is you've got the input-output indicator here, and then you've got the DDR indicator light on top of their corresponding pin. And the way it works is if the light is on, that's an input, so then you can flick the lever and send the data into the computer. But if the light is off, it's an output, and the computer will turn on the light for you. So that's the way that works. It is also interrupt capable. If there's a change on any of the input pins only, a interrupt will be signaled, and the computer can respond to that. I believe it is a interrupt 1.5 level, I think. Okay, I've got it set as a level 2 interrupt. I don't think that's right because a level 2 interrupt is over here. I think that's a level 1.5 interrupt, but I can check that later, I guess. So that's that. The other thing I added was the 16-bit display here, the hexadecimal display. So this allows you to take 2 bytes of information and display them next to each other. Just, you know, set up in a very nice 16-bit manner, so you can view them as 2 individual bytes, or you can view them as one long 16-bit word. You know, it's totally up to you. Either way, probably not needed, but it's cool, you know. The other thing I added was this interrupt mask control. So in the last vlog entry I mentioned that I wanted to give the system a means of masking individual interrupts, and so this is what I came up with. So the way it works is quite simple. It takes a 4-bit code. 3 bits indicate which flag, or indicates which interrupt we are masking or unmasking, and the 4th bit indicates whether we're masking or unmasking it. So it's fairly simple to use, fairly straightforward, and again, we've got 8 interrupts. We're only using 5 at this point, but that means we have 3 interrupts that can be used for anything else that you may want to add to this computer. So speaking of interrupts, we have 5 interrupts. 3 of them, excuse me, are already on the control panel in here. So some stuff has been added to the control panel. First off, the SID and SOD pins from the CPU have been added directly to the control panel. So you can now send serial input data, or the computer can indicate serial output data. Sorry, let me get sidetracked here. What's more, I repurposed the buttons over here. So enter will now write the data, but will not auto-increment the address. Increment will auto-increment, but it will not overwrite the data. And then jump still does what jump has always done. There's just no decrement, so I didn't think it was really needed. But anyway, we've got the reset pin here, which means you can actually signal the CPU to perform an interrupt routine, or sorry, a reset routine, without having to run to programming mode and then exiting out of it. Then we've got 3 resets. We've got reset 1, 2, and 3, and those correspond to their levels. So reset 1 has the highest priority, followed by reset 2 and reset 3. And I believe Watchdog is reset 1.5, so it has a priority between 1 and 2. And the GPIO interrupt is a 2.5 level reset, so that's a priority between 2 and 3. So that's the way that's mapped. The other thing that I did was I gave the programmer control over the clock frequency divider. So and control over the clock itself. So this will actually turn on and off the clock to minimize the amount of lag that the computer puts out when it's idle, because as you can see, this lags quite a bit when the clock is running, and for whatever reason that is running, actually. Should be in reset mode. Weird. Anyway, the user can then, as I said, this turns off the clock so that it reduces lag when it's not running. Then we've got this software control, and so a while ago, I think it was in the last video, I mentioned that the computer can control the frequency of the clock using software. Now that's conditional. If this is on, the computer can select the frequency of the clock. However, when it's off, the user has full control over the clock speed itself. So then I can now select the frequency of the clock using these 2 levers, which is clock speed 1 and clock speed 0. And for some odd reason, that is still running, even though nothing is running. Weird. Oh boy, things are super ridiculously laggy in 1.9. Okay, my computer does not usually do this. It can usually handle this very, very well, but I don't know, Mojang has made it their goal to watch everyone who has a beefy computer suffer. I guess. I don't know. I'm not saying that's the case. It just seems like it. But anyway, that's all the features that I added. And yeah, I think, as far as I'm concerned, SkittleBits as a project is done. It's complete. Which means this is the last vlog video that I will be releasing about SkittleBits. The next video will be kind of a release trailer type deal. But it's probably not going to happen for a while, simply because I do want to document everything here. And not just, take pictures and all that stuff. I actually want to write a proper user manual for the CPU, as well as a basic block diagram of the computer itself. So that's the plan. I want to try and make it easy for anyone who gets their hands on this to understand exactly what's going on. And I'm not sure how long that will take. It shouldn't take too long, but the point being is when I release SkittleBits, I want to release it with its user manual. So that may delay the release of it overall. But in the meantime, rest assured, the project is done, and I am very, very happy with the way this turned out. It's a little slow, it's a little laggy, but you know what? I like it, and it works great. And my last project, Blue Wave Mark II, I had designed it to have a whole bunch of features in there, and I actually gave up on that project because it got too complex. Well, I'm happy to say that this system right here has just about every single feature that Blue Wave Mark II would have had, and it works just fine. So I'm really, really happy with the result. I like the way this turned out. And yeah, I can't wait to release it. So, that said, thanks for watching. I'm going to be doing some paperworks and whatnot and drawing schematics and everything. And yeah, I can't wait to release this to you. So, hopefully you enjoyed. And I'll see you guys in the next video. Bye.